All right, welcome everyone. We'll get started. My name's Jared Hanson, and I'm here from Auth0. And the subject of this talk is beyond API authorization. And in a moment, I'll get into what I mean by that. So the things we're going to cover in this topic, in this talk, we're going to give a brief summary of OAuth. I'm going to assume most of this audience is pretty familiar with OAuth, given the nature of the conference. We'll look at what OAuth provides and what it doesn't provide. We'll look at how OAuth is deployed today to protect APIs in typical scenarios. And then we'll look at what functionality is needed to move beyond API authorization. All right, to start off our look, a brief overview of what OAuth is. This is the diagram that you see if you look at the OAuth specification. It's stylized here a little bit to make it a little bit more pretty than the typical specification document. But at its core, OAuth is fairly simple. You have an application that wants to access a user's data at a given API. And that API is known as a resource server in OAuth terms. So what it does is it asks the user if it can access that data. It'll ask Alice if she wants to allow this, and assuming Alice allows access, this application can now talk to what's known as an authorization server to request access tokens. The authorization server will issue the application the access token, and it can then use that access token to make API calls. It's relatively simple. If you look at the mechanics of how these requests are done, it gets a little bit more complicated, but we're not going to cover that. At a high level, this is the interactions that are occurring. I like to flip that diagram a little bit when I think about OAuth, and I like to reorient it in this fashion. I like to put the user at the top so that it's clear that the interaction with the application is all being done by the user. The other thing that this diagram, I think, makes more clear is it puts the systems on the same level. This helps illustrate the communication channels between these systems. It's clear that you have the application which is making requests over to the authorization server to obtain access tokens, and it's making requests over to the API server to make API requests. What's less obvious from this diagram, however, is that there's a third communication channel here. There's a communication channel between the authorization server and the API. And I like to think of this channel as a tunnel of sorts that runs through the application. The authorization server needs to convey authorization information securely to the API, and it needs to do it through the application itself. So in order to do that, as with any sort of security protocol, you typically need to encrypt this tunnel. And in typical deployments, this is done via the access token. If you're using stateless access tokens like JSON Web Tokens, the token itself will be encrypted, or you might negotiate back-channel communication between the authorization server and the API. But either way, this is one of the most important communication channels that's occurring in OAuth in order to actually secure API access. Now, one of my favorite lines from the OAuth specification is this one. The interaction between the authorization server and the resource server is beyond the scope of this specification. Now, I understand why they did that. It leads to some nice layering, and this stuff is fairly complicated to begin with. But for a protocol that's designed to offer API protection, it's kind of interesting that it's not defined by the specification. So the subject of this talk is really all the things that are out of scope of OAuth. If we look then at what OAuth is actually defining, it's defining what I call a token issuing protocol. It's the protocol that issues tokens from the authorization server to the client and defines the interactions between the user and the client and the authorization server. What's actually important in terms of API authorization, however, and API access, is this channel, what I like to think of as the token accepting protocol, if you will. So we're going to talk about what goes on in this channel and how to do secure API access. We're going to talk about this in the context of a use case, document sharing and collaboration. This isn't particularly relevant. You can translate this to your own application use cases. I just like to use this one because it makes the interactions fairly clear. We're going to look at how you might do this using standard API authorization today. And then we'll look at the ways that that breaks down and the shortcomings and how we might think about solving those shortcomings. So first of all, these are the systems that are going to come into play as they do in any OAuth scenario. We have the authorization server. on the left, the application in the middle, and the API on the right. Once this application initiates an OAuth request, we'll bring our user into the play, and Alice will see a dialog that typically looks like this. Application X is requesting access to view and edit your documents. Now, once Alice accepts and allows that access, the following occurs. Now, we'll walk through what's going on here because this is kind of key to understanding some of the weaknesses and shortcomings in OAuth. So the first thing that happens is that the authorization server issues an access token. The access token is just a string that the client relays over to the API. In this case, I'm using JSON Web Tokens for illustrative purposes, but it can really be anything that the resource server understands. Once the application has this access token, it makes a typical API request, in this case to get a document, and it carries the access token in the authorization header of the HTTP request. Now that the API has that access token, it can look at the payload that's occurring over this channel, and the payload is basically the claims that's in the access token. If you're using JSON Web Tokens, these are typically 3-letter abbreviated words, and the claims that often show up are the issuer, which defines the entity that issued the access token, the authorization server, the audience, which is the intended recipient of the access token, which is the API, and then claims with authorization information, in this case, a subject claim that says 501, which indicates Alice's user ID, as well as the scope of access that Alice is allowed, in this case, read and write access. When the API receives this access token, it needs to take a number of steps in order to verify it and allow access. First, it needs to decrypt the token and verify any signature that's present on it, and ensure that that token was issued by something that it trusts. So in this case, api.docs.com trusts accounts.docs.com. Then it checks the audience to make sure it's actually the intended recipient of that access token. So this checks out that api.docs.com has received the token with that audience value. It then checks that the scope is sufficient to permit access by the request. So in this case, we're making a GET request. The scope has read as a value. That all checks out. And then finally, it does another check to make sure Alice actually owns the document. So in this case, Alice attempted to access document 1234, and that's a document that Alice owns, so it's permitted. If this document happened to be owned by Bob, the resource server would deny access. In this case, it's clear that the resource server is also applying its own access policies that are specific to the resource itself. Now, what do I mean when I talk about API authorization? What I mean by that is that this access token was targeted at a broad API. And that API is really a facade over a much larger and potentially more complex set of individual resources. So the API is just all documents that are served by this API, not a specific document. And in other applications, you know, the interaction of the resources and how they relate to each other might be even more complicated than that. There's a couple problems that arise when you look at these type of scenarios. The first is that the application is tightly coupled to the cloud service itself. You typically see a service provider provides an API, it'll document the API, and it'll document the authorization server that governs access to it. Developers then go and write code that assumes that these two are tightly bound often. This isn't purely an OAuth problem, but OAuth kind of exacerbates the issue. The document's owner is assumed to be the person requesting access. So in this case, Alice is granting an application access to her own documents. However, there's oftentimes use cases where you have sharing between people where you want to access someone else's documents. And that's not really well captured by current OAuth models. The consent granted by the user is often too coarse-grained. My favorite example of this is GitHub. I have a bunch of public and private repos on GitHub and a number of services that want to integrate with GitHub. And anytime I connect them up, they often ask if they can have all the access to all my repos, which is oftentimes something I don't want to give. But the level of granularity that OAuth provides to GitHub and how they've implemented it is too coarse-grained to let me pick specific repos and specific scopes of access. Finally, the access control policies are located at the resource themselves. Now, I say that these are problems, but if you're implementing OAuth and you're running into these issues, it's not really a problem. This is kind of like the state of the art in OAuth, and you're doing OAuth right if you have these things. But these things are often things that come up. So how would we look to solve these issues? We're going to look at 5 different directions. The first is, can we discover the authorization server from the resource being accessed? If you look at how most applications are built, the first thing that happens when you go to an application is that they'll just prompt you to log in and authorize that application access. They typically do this the first thing without even the user trying to access anything in the first place, and the access request is often requesting too much access. So can we drive that process by having the application actually attempt to access the resource itself and then dynamically make authorization requests that are needed on demand? That would work using a pattern somewhat like this. The application would first make the HTTP request over to the API. In this case, it's unauthenticated, so the server issues a challenge. And that challenge includes an additional parameter issuer, which defines the authorization server that can issue access tokens to access this API. There's some specification links at the bottom if you want to read more details. I'm just kind of covering the basics here. And you can download the slides to read those in more detail if you're interested. But this pattern, what it allows us to do is now the application can use RESTful principles and follow links in order to determine which authorization server to make requests to. This allows the resource server to be decoupled from the authorization server and keep the client decoupled as well. There's another specification that's kind of being discussed on some of the IETF mailing lists that does a similar thing with just a slightly different syntax. And I wanted to point it out here as well, just to say that multiple people are kind of talking about this problem. In this case, the link to the authorization server is carried in link headers rather than in the authentication challenge itself, but it's conveying the same equivalent information. So again, if the specification were implemented as such, you just follow those links applying RESTful principles. Now, when the client follows that link in order to obtain an access token for this resource, it makes a standard OAuth request over to the authorization server. So here you see the request to the authorization endpoint. It's a standard OAuth request with all the typical OAuth parameters, but there's an additional parameter there, which is the resource parameter. And that identifies the specific resource that that client had attempted to access and was denied access to. So in this case, it's the specific document at our document sharing API. Now, we're going to skip over the user interaction here and jump straight to the access token itself and see the differences here if this model were to be applied. The major change that this allows us to do is the audience value can now target a specific resource rather than a broad API. And there's a couple of things that become interesting with this, is now it's not ambiguous anymore what that scope allows. So in our previous example, when we had a scope of read, we didn't know if that would allow access to any individual document because Alice may or may not own all the documents at the API. But in this case, we can be assured, as long as the authorization server is evaluating policy correctly, that Alice does in fact have read access to this specific document, and the API no longer has to do any additional access control. The second direction that I want to talk about is negotiating the parameters of the tunnel between the authorization server and the resource server. In order to issue access tokens that these two systems can interpret, the authorization server needs to know a number of different pieces of information. It needs to know what scopes the resource server understands, what types of access tokens it understands, what encryption algorithms it supports, and things of this nature. I'm just going to put up a couple references to specifications here. There's a number of properties that need to get negotiated, and I don't want to go into detail on all of them, but these provide good starting points. There's OAuth 2.0 protected resource metadata and some resource registration APIs that UMA defines that both give information like this. I think the metadata that they defined is a start. I think there's additional things that need to be covered there. One thing that often gets assumed is that the tokens that travel over this channel are JSON web tokens, which is fine because that's the only standard that's really taken off and seen adoption. But it's not the only form of token out there, and I think it's just worth highlighting that we want to keep some flexibility to allow other token formats to be negotiated, and that's something that's not present in the metadata specs today. The third direction, add the ability to request access during OAuth user interaction. The typical dialogue that a user sees in OAuth requests is this one. Again, application X is requesting access to view and edit your documents. The application is asking for access to something that the user already has control over. But there's other use cases that are really common, like this one that you often see if you use Google Docs. Sometimes you want to request access to something that someone else has control over. What if Alice wants to access a document that Bob owns? I think it'd be great if we could move these type of user interactions into the authorization server itself and allow all resources to take advantage of them without having to code individual policies themselves. In technical terms, we need to introduce another end user role into OAuth. The role that OAuth defines today is that of the resource owner. It's the entity that owns the resource that is protected and grants access to it. Typically, like Alice owns her own documents. But the other case is that of a requesting party, which is an entity that uses a client to seek access to a protected resource, and that party may or may not be the same as the resource owner. So if Alice is sharing documents with Bob, and Bob's the requesting party, and Alice is the resource owner. Let's go back to the flow that we were looking at earlier to see how this interaction would occur. So once again, the application just makes a request to the API and requests document 1234. It's unauthenticated, and so the API responds with that challenge. The application then follows that link and makes an authorized request over to the authorization server, indicating the resource that it's attempting to access. And now, instead of a consent dialogue, the dialogue that Alice would see is that, oh, that is Bob's document and you don't have access to it. But you can request it if you want to. If Alice then presses the request access button, she'll see a message such as this saying, hey, your request is currently being approved. You'll get an email if and when it's approved. At this point, the authorization server would reach out to Bob via email or Slack or whatever channel he's reachable on and tell Bob that Alice is requesting access to this particular document. And then Bob can respond to allow or deny that, and Alice will get a notification when Bob has made a decision. What this does is take the consent process out of band to the OAuth transaction and also allows it to be delivered to another user who's actually the resource owner. And then if this all occurs, then the OAuth process will complete once Bob has approved the process. And I think it'd be really interesting if we could do something like this in typical OAuth servers. Direction number 4, we need to avoid overburdening the user with consent prompts. If we were to get fine-grained access control like this, where you're requesting access to individual documents or individual resources, it'll quickly become burdensome to the user when they see consent prompts popping up all the time. And that's not good for the security of our systems either, because it just conditions users to always press allow and never really interpret the scope of access that they're granting. So the typical use case for this is that Bob and Carol typically need Alice to review the documents that they create. So Bob might share documents with Alice via the document editor, and Alice gets an email. Alice clicks this email to the link to the document that Bob has just shared with her, and the application fetches that document. Once again, Alice has no access token for this particular document, so the request comes back unauthorized. However, there's a shortcut here that we can take advantage of. The issuer of accounts.docs.com has been seen before by Alice's application. Alice is logged into this authorization server when she's writing her own documents. When Alice logged in previously, she was issued a refresh token in the OAuth protocol that allows her to request access tokens without user interaction. So the client can now take advantage of this refresh token, and instead of redirecting redirecting Alice to the authorization endpoint, it can just issue a token request directly to the token endpoint using the refresh token that it had obtained previously. Once again, the resource parameter is now an extended parameter on this request that's indicating the document that Alice is requesting access to. In this case, it's the document that Bob shared with her. The authorization server at this point has all the information it needs to evaluate this request. It knows that the refresh token was issued to Alice, so it knows who Alice is. It also knows the resource that she's attempting to access, and it knows that Bob is the owner of that resource. It can also see, potentially, that Bob has shared that resource with Alice, and as such, it can issue the access token directly to the application, and Alice is not prompted for any intermediate access control prompts. So now this whole interaction has occurred, and Alice hasn't been bothered. It's all been completely behind the scenes. Once again, the audience value in this access token is that particular document that she was issued, that she was attempting to access. And the authorization server has evaluated the policies for that, so we know that that access can occur. The fifth and final direction is that I think it'd be interesting if we could evaluate access control policies at the authorization server rather than the resource itself. Hopefully this has been pretty clear that this needs to happen for this type of model to occur. In this case, what we want to do is take the policies that you might set up on a document itself, like this, and move those policies to the authorization server where the authorization server can enforce them. What's interesting about this, I think, is the following. We've done a really good job as an industry with single sign-on, which has allowed us to consolidate users into a single centralized directory. It makes it much easier for administrators to manage their employees. However, if you look at cloud applications, all the access policies for those applications continue to be at the applications itself. If you use 10 different cloud applications, you have a bunch of authorization policies that exist there. What if we could centralize those policies the same way we've centralized authentication with SSO? I don't have any particular answers for that, but I just think that's an interesting challenge to solve, and if we could solve it, there would be a lot of management benefits. So to summarize, the directions that we need to head and to take OAuth in order to move beyond just broad-based API access is to discover the authorization servers from the resource being accessed. This allows us to decouple the clients from the APIs. Negotiate the parameters for the tunnel between the authorization server and the resource server. We need to add the ability to request access during user interaction. Once again, this allows us to do person-to-person sharing scenarios. And when we do that, we also need to avoid overburdening the user with the consent prompts. And finally, if we can evaluate access control policies at the authorization server, this allows us to centralize those things and simplify the management, just as SSO simplifies authentication. And with that, any questions, feedback?
I guess I'm supposed to use the mic. So I saw references to UMA, and so I'm most curious as to where you think there's concerns between UMA and this, because every single direction you highlighted is something UMA's solved.
Yes, so I think the biggest concern that I have with UMA is that it's just, I think, generally very complex. And if you look at the interactions that's occurring, you have API calls from the resource server to the authorization server and to request kind of access rights. That seems kind of redundant, given that the client can do that with the OAuth request itself. The other thing, too, is that I think the refresh token exchange can be used instead of the persisted claim tokens and the various things that UMA defines. And the basic, I guess, like argument that I would make is that we can do most of what UMA is offering with pure OAuth primitives and not introduce any new primitives, and thus we can simplify the implementation requirements of it.
Yeah. And I guess for me, I think that may be true for some simple sharing kinds of use
Mm-hmm.
So I think you run into problems when you get, depending on how the authorization policies are being set up or what the resources are. Sometimes a pure URL might not be sufficient to describe a resource or to describe what kinds of scope should be allowed on that resource.
Mm-hmm. Yeah, and agreed. And so like just to highlight, like the directions that this stuff is mentioning aren't necessarily final or they don't solve all the problems. They're just sort of directions being proposed that are interesting to explore. And then I think part of the reason to highlight them is just to like have these type of discussions of what's missing here, or what can we do and what can't we do and how can we simplify things. Yeah. Go ahead. So a lot of this is kind of just ideas that are being floated to like, solve certain problems. There will definitely be performance concerns. For instance, one of the obvious trade-offs here is that you potentially now have many more access tokens and many more access token requests. So that might be potentially not doable in certain applications. I think like, as with everything in OAuth, there's a lot of trade-offs between how these things work. So there's nothing wrong with OAuth as is, and if that's serving applications just fine, you shouldn't change it. But if you run into some of these issues, you might actually need some of these capabilities. So it's the balance to achieve. Yeah.
Big fan of what you're describing here. Curious on the implementation side of this, and I realize this is still theoretical idea you haven't done yet. Do you have any concerns that you're putting too much application-specific information inside the authorization server that will make it difficult to implement, difficult to maintain?
Yeah, so I mean, I think that goes to the authorization policies, which is potentially the most complicated stuff you'd be shifting over to the authorization server itself. So yeah, that's why I raised it as kind of a challenge. I'm not sure, like, people have attempted to find kind of generic authorization policy formats. And
what about like XACML, Alpha, stuff like that?
yeah. Yeah, so that's potentially one, XACML is something you could implement to drive this and to publish the policies. Yeah, I didn't cover that in the talk, obviously, but that would be one potential option. Yeah.
Is that something you guys are interested in, XACML on your authorization server to make that happen?
You guys by Auth0 specifically. I mean, we've looked at XACML. We haven't implemented it. It's again like a fairly complex spec for people to implement and understand. So I'd be interested in seeing something simpler result from it. But what that is still undefined. So XACML is probably the best kind of standard specification for that right now. I'm personally haven't looked at that much yet, so I can't comment, but I'll definitely, Alpha is the name of it. I'll look into it. Mm-hmm. Thanks for that.
What about endpoints that return multiple documents? Like how do you negotiate whether they have access to them or not?
Yeah, so I think that's potentially one of the challenges to solve in terms of authorization policies. I think I don't have any specific answer, but if the endpoint returns multiple documents, it could be a different identifier, a different URL of sorts, so that you could know that that has different scopes by chance. Like you could put those type of things in the scope itself. That's just one idea, but that would be something to resolve in this type of situation. This is mostly optimized for something where the resource is kind of well defined in a specific item. Yeah. Mm-hmm. Yeah. Sure, yeah. I mean, as with any sort of like access, you can stuff whatever claims in it that you want. So as long as the resource server and the authorization server know the claims that need to go in the token to sort of identify if you're bundling multiple documents, then that could be done. But I don't know of any deployments that do that today. You could put multiple audiences in that JSON web token if you wanted, which is potentially a possibility.
Yeah, you just have to be careful that you don't leak information out about documents that the user doesn't have access to.
Right, right. Mm-hmm. That it? All right, thanks everyone.